जैसा कि लास्ट लेक्चर पे हम लोग एनर्जी की बात फिर से किए थे और एनर्जी की बात किसमें किए थे, एनर्जी इन अ केमिकल सिस्टम और प्रोसेसेस। ओके, और जैसे कि हम थोड़ा सा हम आपको बताना चाहेंगे फिर से कि केमिकल प्रोसेसेस में या केमिकल सिस्टम में और एनर्जी का किस हिसाब से हम लोग इंटरप्रिटेशन देखे थे। उसमें हम आपको बताएं, फिर से बताए थे कि हीट क्या होता है। हीट में भी डिफाइंड एज अ डिग्री ऑफ कोल्डनेस और हॉटनेस। ओके, और बहुत पहले ही बता चुके थे कि क्या है, हीट इज अ फॉर्म ऑफ एनर्जी है और हीट फ्लो कहाँ से होता है, हायर टेम्परेचर टू लोअर टेम्परेचर। उसके बाद हम आपको उसके प्रोसेसेस बताए हीट का। फिर हीट के बारे में जब हीट डिस्कस कर लिए, हीट इज अ फॉर्म ऑफ एनर्जी बता दिए। उसके बाद हम क्या भी बताएं कि जो अगर हम केमिस्ट्री में आते हैं केमिकल रिएक्शंस में, तो केमिकल रिएक्शंस में क्या होता है, एक पार्ट रिएक्टेंट होता है, एक पार्ट क्या होता है, प्रोडक्ट होता है। रिएक्टेंट और प्रोडक्ट, रिएक्टेंट और प्रोडक्ट में ऐसा भी हो सकता है कि रिएक्टेंट में प्रोडक्ट जब कन्वर्ट हो रहा है तो हीट रिलीज हो। ऐसा भी हो सकता है कि रिएक्टेंट को कुछ हीट देनी पड़े जिससे कि वो प्रोडक्ट में कन्वर्ट हो सके। उसके बाद हम आपको बताए थे कि ये एंडोथर्मिक और एक्सोथर्मिक रिएक्शंस होती है। ठीक, एंडोथर्मिक और एक्सोथर्मिक रिएक्शन से पहले हम आपको क्या बताए थे कि बॉन्डिंग एनर्जी क्या होती है। तो बॉन्डिंग एनर्जी बेसिकली किसी भी एटम्स टू एटम और मॉलिक्यूल्स इनसाइड द मॉलिक्यूल्स उसकी क्या स्ट्रेंथ होती है, वो उसकी बॉन्डिंग एनर्जी होती है। ये भी बताया कि जब कार्बन को सिंगल बॉन्ड होता है, कार्बन को डबल बॉन्ड होता है, कार्बन को ट्रिपल बॉन्ड होता है, तो जैसे जैसे बॉन्ड्स बढ़ते जाते हैं वैसे उसकी बॉन्डिंग स्ट्रेंथ क्या होती है, बढ़ते जाती है। ऑब्वियस सी बात है कि बॉन्ड एनर्जी बढ़ते जाती है। तो ये बात हो गई प्रीवियस लेक्चर्स में हम क्या भी किए थे। प्रीवियस लेक्चर्स में हम आपको सारी चीज़ें डिस्कस किए थे इसके पॉइंट ऑफ व्यू से, केमिस्ट्री के पॉइंट ऑफ व्यू से। केमिस्ट्री के पॉइंट ऑफ व्यू से हम आपको बायोकेमिकल एनर्जी के बारे में बताए थे। ऐसे बायोकेमिकल एनर्जी के बारे में ये बताए थे कि मतलब अगर ग्लूकोज है वो एक ऑक्सीडेशन रिएक्शन देता है तो वो कार्बन डाइऑक्साइड को वाटर में कन्वर्ट होता है। आज वही यूनिट 1 को कंटिन्यू करते हुए आज हम फिर से हीट की बात करेंगे, सॉरी एनर्जी की बात करेंगे, बिकॉज वी आर स्टडीइंग अ सब्जेक्ट हुज नेम इज एनर्जी साइंस एंड इंजीनियरिंग। तो जहाँ कहीं भी एनर्जी होगा, जहाँ कहीं भी साइंस की बात होगी, इंजीनियरिंग की बात होगी, तो उसका हम क्या करेंगे, एक व्यू देखेंगे, एक इंट्रोडक्शन देखेंगे कि एनर्जी साइंस और इंजीनियरिंग में ये सारी चीज़ें होती हैं। तो उसका एक ब्रीफ बताएंगे, ना कि उसका पूरा पास्ट बताएंगे, उसका एप्लीकेशन बताएंगे थोड़ा बहुत, उसका पूरा जो है न्यूमेरिकल से आप और आपके क्वेश्चन क्वेरी होंगे कि इसके आप न्यूमेरिकल सब नहीं बता रहे, तो वो न्यूमेरिकल हो सकता है। जब अगर हम बात करें थर्मोडायनामिक साइकिल की, थर्मोडायनामिक साइकिल आगे चलिए क्या हो जाएगा, तो आईसी इंजन जब पढ़ेंगे तो सारी चीज़ें जो है ब्रॉड में पढ़ेंगे। ठीक है, फिलहाल हम आज यूनिट 1 का टॉपिक स्टार्ट करेंगे और यूनिट 1 का टॉपिक स्टार्ट करेंगे वो केमिकल प्रोसेस, केमिस्ट्री में जो हम चीज़ें एनर्जी के बाद एनर्जी बताए थे और एनर्जी इन द केमिकल सिस्टम और प्रोसेस बताए थे। उसके बाद फ्लो ऑफ CO2 का थोड़ा सा आज बताएंगे हम आपको, जैसे कि फ्लो ऑफ CO2। तो फ्लो ऑफ CO2 अगर सपोज दैट इफ द CO2 इज stored inside the cylinder, as you can see in this slide, a cylinder which contains CO2 in the liquid form at a very high pressure atmosphere। तो क्या है कि एक सिलेंडर है जिसमें CO2 स्टोर है इस फॉर्म में, लिक्विड फॉर्म में, और हाई प्रेशर है। ऑब्वियसली बात है, हाई प्रेशर जब होगा तो क्या भी होगा, हाई टेम्परेचर के साथ ही होगा। फिर यहाँ पर देख सकते हैं प्रेशर रेगुलेटर। सपोज दैट इफ यू हैव टू कंट्रोल द फ्लो ऑफ CO2, because you have to cover a overview of CO2, flow of CO2. Now with the help of this instrument, and this instrument is CO2 pressure regulator, and the pressure regulator must have a component. It allows you to control the output level of CO2 at the desired pressure. It comes with the indicator. Suppose that if you are talking about the pressure flow of CO2, okay. Now if you have to control flow of CO2, then you will have to use pressure regulator, and this pressure regulator assisted to control the pressure of CO2 and whatever you want the pressure value of CO2 at the output. Okay. So finally it comes with the indicators. Now the next slide, as you can see in this slide, a needle valve. Here you can see a needle valve. Basically a needle valve is a needle valve also uses for to control the CO2 more accurately. If you have to control the CO2 in some system to regulate the cyclic path, then in that system we can use needle valve to control the flow of CO2 more accurately. Okay. Now in the same way, if you have to count the bubble of your CO2 this is very obvious. When the CO2 is flowing inside the system, then obviously due to the lower pressure inside the cylinder, bubble formation may be started. So if you have to count them, then you have to use a bubble counter, and the bubble counter diagram you can see here. This type of device can use to count the CO2 bubble. Now, I think this is the last slide related to flow of CO2. Basically, if you have some questions is arising in examination, and what do you understand by flow of CO2, then I explain you some devices which may be used to control the CO2 pressure, and if you write those in your answer for 5 marks question, then definitely this slide may be very helpful to cover this question, and you would be deserved for to obtain 3 to 4 marks at least out of 5 marks. Now, in this slide, as you can see in this slide, the diffuser is mentioned in this slide, and what is the role of diffuser? You can see in this slide. This is the application of diffuser. Basically, the main job of diffuser is to break down the CO2 bubbles into tiny parts. If you have to separate any CO2 bubble in the tiny or small parts, then you have to use diffuser. And why we would like to break the CO2 bubbles? Definitely there is a motive to break the CO2 bubble. Actually, it helps the plant absorb the CO2 easily. Okay, because in the botany section, plants feels very comfortable when the CO2 bubble is in very tiny part, is in very small parts to absorb them. That's why we diffuse the CO2 bubble into the smaller parts, many parts, because of the plants are very comfortable to take CO2 and easily they can absorb. And how many types of diffuser can be? The first one is the glass diffuser, and the second one is the external diffuser. Now, in such a way we have completed the section of flow of CO2. Now I would like to start the next topic. I think if you will see the Unit 1 syllabus, then the next topic you will get, that is entropy and temperature, carnot in them. Actually, before we start, these topics, I would like to say that these topics having a very general books, and those books are trying to discuss point to point to elaborate the graphical representation of EB as well as TS. Okay, now suppose that you have studied about the Boyle's law. And what Boyle's law says, for the constant pressure, the volume is directly proportional to the absolute temperature. Boyle's law. And there would be some keywords like pressure, volume as well as temperature. Now I would like to start the term entropy and temperature. Entropy and temperature, by mistake the temperature is not here, and actually if a slide is represented in the way to give the contents related to entropy, there may have some points. First one is introduction, the second one is various types of disorder, example of disorder, definition and expression of entropy, importance of entropy in geochemical thermodynamics, application of entropy, conclusion, references, etc. But what happens because the very introductory portion or the brief knowledge you have to absorb here for the term entropy as well as temperature. Now, before we discuss entropy, I would like to ask you the question, what is the temperature? I think already discussed the temperature term, because before we discuss the heat as well as energy term, I discussed the temperature term. Actually, what is the definition of temperature? The temperature is the degree of hotness or coldness. Okay. What happens if you feel warm, if you feel cold? Then this is the process of heat flow. If the heat flow, if the heat flows from you to the body, then it means that you feel cold, and if the heat flows from body to you, it means you will feel warm. Okay. And basically the general term temperature measured in the form of Kelvin, and if you have measured some temperature in the form of degree centigrade, then you have to convert this value to Kelvin by adding to 73.15. Now see, actually the definition for entropy is not given perfectly in any books or in anywhere, but here I would like to state some lines about the entropy. Now this line is related to the entropy terms. Here you can see some lines is written over here, and one question is asking by this slide. The question is, what is entropy? Actually the word is entropy. The word entropy is sometimes confused with energy. What happens sometimes we relate the entropy term with the energy, but although they are related quantities and they are distinct. Okay. What happens if we relate the entropy with the energy, then in some way they are very distinct. Okay. If we want to state the term entropy may be defined as the degree of randomness or disorderness. Suppose that in any classroom, and the teacher is in any classroom, the students are there for purpose of study, and the teacher is very strict, and any student cannot think except the study, and that's why in that classroom the degree of randomness is almost zero, not here. Entropy energy measures the capability of an object or system to do work. Okay. जो सिस्टम और ऑब्जेक्ट की कैपेबिलिटी होती है किसी वर्क करने की, उसको हम क्या कह सकते हैं? एंट्रोपी और एनर्जी. On the other hand, is a measure of, you can see here, is a measure of disorder. Already told you, the degree of randomness or disorderness is known as entropy for that type of system. Now, here, what disorder refers to is really the number of different microscopic states a system can be in, given that the system has a particular its composition, volume, energy, pressure and temperature. By microscopic states, we mean the exact states of all molecules making up the system, and it means the disorderness refers to really the number of different microscopic states like composition, volume, energy, pressure, temperature, etc. With the help of this formula, you can evaluate the value of entropy. Change in entropy exists always. The Boltzmann constant multiplied by the logarithmic of the number of possible states scale of it, then it will give you entropy. Now the next slides, entropy. Entropy, the thermodynamic property. Thermodynamic property, a quantitative measure of disorder. Actually, I would like to say that entropy is the term, the basic E of thermodynamics, because the thermodynamics is always defined with the help of three: energy, equilibrium, as well as entropy. But here we have to study entropy in brief. So I would like to forward this slide without absorbing any more time. Because this is the origination here, and the concept of thermodynamics, and basically एंट्रोपी जो होता है, एंट्रोपी कॉन्सेप्ट थर्मोडायनेमिक्स का सेकेंड लेवल होता है. इट कैन बी विजुअलाइज ड्यू टू द प्रोसेस ऑफ एक्सपेंशन, हीटिंग, मिक्सिंग एंड रिएक्शन. एंट्रोपी एसोसिएटेड विद द हीट एंड टेम्परेचर. एक्चुअली क्या होता है, एंट्रोपी always associated with the heat and temperature, and its formula is change in entropy is equal to change in heat energy upon absolute temperature. Now, how many type of disorderness or randomness can take place in the way to describe entropy? Now in this slide, actually I already told you the entropy term reflects you the degree of randomness or degree of disorderness. Okay. Now how many types of disorderness can be in the form of entropy? First is positional disorder. If I am talking to you about the positional disorder, it means the position of atoms will get changed. It means some temperature or some pressure are decreasing or increasing, and due to that the kinetic energy of molecules will get changed, and then position also changes, and that's why the disorder will take place and the entropy goes to some non-zero value. Second, vibrational disorder. Due to the vibration, also disorder takes place. It means positional disorderness and vibrational disorderness. Now, what will be the lines for the vibrational disorderness? Whether the atoms vibrate about an average position. Now, the configurational disorder. vessel. And due to the partition, what happens? The entropy is lesser, because in this case the degree of randomness is lesser. That's why the entropy is lesser. But if the removable partition is not in the second case, in box 2, then what happens? The entropy will increase. Partition is removed, box is second. If the box is second, then it is very obvious concept that the randomness term is very active in the case of box 2. Now, the box 1 entropy is lesser in comparison to box 2 entropy. Now see, what may be the definition of entropy as well as expression of entropy? Already told you the entropy may be defined as the property of a system which measures the degree of disorderness or randomness in the system. Actually, this is the Greek word which means transformation, and entropy term is denoted by capital S. The Clausius was convinced of the significance of the ratio of heat delivered and the temperature at which it is delivered. The point says the Clausius stated that the change in heat upon absolute temperature is known as entropy. Now, here with the help of formula, S is equal to Q by T. And if we have to define the term entropy in another way, the first formula is formulated by the Clausius, and then S is equal to Q by T. Or change in entropy, I think this should be Ts and this should be dQ. The change in entropy is equal to the change in heat over the temperature. Second point says entropy is the sum of entropy due to position. Now, if you have to integrate the all randomness, whatever the randomness is taken place due to the vibrational disorderness or positional disorderness or configurational disorderness, then due to these disorderness the entropy is active. So if we got the summation of these disorderness, then we can calculate the overall entropy. Now this point says the entropy is the sum total of entropy due to positional disorder, vibrational disorder and configurational disorder, that is randomness due to the charge of state. And S is equal to Sp plus St plus Sc. Sp is what? Positional and configurational, and another one is vibrational. Now, if we have to formulate the term entropy, follow a process. If the process goes from 1 to 2, if the process point 1 having the entropy is S1 and point 2 having the entropy is S2, means entropy changes from S1 to S2, then what happens? From the point 1 to 2, the change in entropy is S2 minus S1, and this change in entropy is the integral part of change in heat to the absolute temperature. And that's why if we write T delta S is equal to dQ or TdS is equal to dQ, and this is the second law expression. Suppose the process is undergoing change at constant temperature. And this expression is helpful to evaluate the entropy term. From the first law we know that energy can't be created nor can be destroyed, can be converted from one form to another. And for the cyclic process, if we are defining first law of thermodynamics, in a closed vessel, the net heat taken from the surrounding is equal to the net work done by the system. If we are covering the first law of thermodynamics for the process, then it may be equalized is equal to equalize as dq is equal to du plus dw. Now here this formula, change in energy is equal to E minus work done, and now here you can see the change in energy maybe the change in energy equals to the change in heat minus change in work done. This is a very obvious case. The dq, if we are talking about the rate of change in energy or a change in heat, then we always know that the heat is a low grade form of energy and work done is a high grade form of energy. And here change in energy is equal to dq minus pdv, because dw is another formula in the form of pressure as well as volume, that is P into dv. So here we can also another formula, delta S is equal to P dv over T. This formula you have to keep in your mind. The change in entropy is equal to change in Cp into ln T2 over T1. Now I would like to tell you the significance or importance of entropy in geochemical thermodynamics. The aim of thermodynamics in geochemical terms is to generate a set of properties which helps to predict the direction of chemical process. Actually, if we talk about the direction of processes in geochemical section, then this is possible because of we have the concept of entropy. And the second point, the second law starts with the simplest term, is there an increase in entropy in every natural process. All we know that the universe having the infinite entropy. And the last point says the degree of order or disorder in a system may be described in terms of probability or improbability of observed state. Here some examples are given. For example, distribution of energy in geochemical system is the one way of expressing. And another point is given over here. It is noted that all the natural processes are spontaneous and unidirectional. Means entropy is a reversible process. Thus, this rate disorderness in the geochemical process can determine the concept of entropy. Now, I think the temperature and entropy slides is about to be over. Here, the application of entropy. The application of entropy, like that, experimental work in mineralogy and petrology. If we see the works from mineralogy and petrology, then there is always an application of entropy. Now the second point, that is thermobarometric models of various thermodynamic formula or equation by which pressure and temperature can be determined. And the last point is the model is calibrated through experimental techniques. If we have to calibrate the models with the experimental techniques, then that techniques may be the behalf of entropy. That's why we can say the calibration of the model through the experimental techniques and an application of entropy. Now, in this slide, there is a conclusion of entropy term. And this slide says the entropy is applied in the model to measure the disorderness or randomness of the system through the temperature as well as pressure of the block. The last point says about the thermobarometry. That's an excellent case study when the application of the thermodynamic parameters are involved. Here the conclusion term, actually already told you that that section was concluded. Some points are here. It can be explained by the S equal to 2 by term point by the numerical cells already discussed. And the entropy is mainly associated with the heat and temperature, because this formula you can see over here as is equal to Q by T. That's why entropy is mainly associated with heat and temperature. And the type of orderness, already told you, positional, vibrational as well as configurational. And the last point, the thermobarometric model is an excellent case. This point says that this is an ideal engine. If the carnot ideal engine, if we want to see a diagram, and here you can see the hot reservoir is over here, and then after the hot reservoir, the heat flow direction is shown here, and in the center position the engine is placed over here, and the cold reservoir is here, and some heat is rejected. The cold reservoir means hot reservoir, you can say it as a source, and cold reservoir you can say it as a sink. In starting, some heat is supplied to the engine, and when the heat is supplied to the engine, then engine goes convert this heat into work, but it is low grade energy. That's why some heat is rejected to the cold reservoir. And starting में क्या होता है? In starting we assume that the heat capacity is infinite for the cold reservoir, and reaction, no effect are seen on the reservoir. Heat capacity is to be considered infinite as an ideal perception. Now, if we have uh, the cyclic stepwise process, then there may have some steps. First step 1, step 2, step 3, step 4. Step 1 says the process is isothermal reversible expansion. Second one, adiabatic reversible expansion. Third one is isothermal reversible compression, and fourth one is adiabatic reversible compression. Now, step 1, isothermal expansion. The term is isothermal is maybe very obvious for you, because this process is isothermal. That's why the temperature is constant in this case. If the temperature is constant in this case, then here you can see the process from A to B. The process from A to B, what happens? Isothermal expansion process takes place from A to B. Then what happens? This is a closed cylinder, and inside the cylinder, insulated piston is held over here, and in the cylinder some fluid gases are filled, and due to the isothermal expansion process, this piston goes in upward direction and the heat supplied to the cylinder, and the temperature is constant. Now, in the next process from B to C, the adiabatic expansion. The adiabatic expansion, it means we are talking about the process for B to C. For B to C process, the heat transfer is 0. That's why W2 is equal to CV times of P2 minus CV of T1. And this work done will be performed in the case of adiabatic expansion process. In this case, what happened from B to C, when the reversible adiabatic expansion process takes place, then the value of pressure decreases, volume increases. Because the pressure decreases, that's why temperature also decreases. And I want to say that the adiabatic expansion process is a very short duration. That's why no heat transfer takes place. Now, I would like to tell you about the step number 3, isothermal compression. In the isothermal compression, in the case of isothermal compression, the temperature is constant, and if the temperature is constant and the process goes from D to C, and temperature is constant, what happens? The compression takes place. If the compression takes place, then this is very obvious. At the constant temperature, if the compression takes place, then the value of pressure increases, and when the value of pressure increases, then the volume decreases. It means the piston is going in downward direction. And this is a process from C to D here. In C to D, you can see the value of pressure which increases from D3 to D4. Now, the last step is step 4, that is adiabatic compression. Already we know that during the adiabatic process, the heat transfer is 0 to V0, and W4 is equal to CV into T1 minus T2. What happens? The pressure increases, volume decreases, and temperature increases. Why the volume decreases? Because this is the for the carnot cycle. Efficiency means the ratio of work done obtained in a cycle as well as total heat done. Here is the formula. Efficiency is equal to net work done upon input heat supply, QH minus QC upon QH, and after the calculation of QH QC, we get the efficiency for the carnot engine, that is 1 minus T2 upon T1 or 1 minus T2. Here you can see T1 is the maximum value of temperature, while T2 is the minimum value of temperature. Now here pH upon pH, we can see the efficiency is less than 1, but this efficiency is the maximum value, having the maximum value, because the process is reversible and no friction takes place in the way to piston as well as cylinder. This is the formula for the efficiency of carnot engine. Effective ways to increase the efficiency. If you have to increase the efficiency, then here are some points. You have to increase the heat source at and lowering sink temperature. And sink source temperature T2. Now some application of carnot cycle. First application of carnot cycle is diesel cycle, and another one is heat engine. And finally, I would like to say, because the carnot cycle, carnot engine does not exist practically, but this is used in the way to establish the comparison in between some engine and one engine is fixed in all cases, and that engine is carnot engine. Let's summarize. Hot reservoir, cold reservoir. From hot reservoir, heat is supplied to heat engine, and after supplying heat engine, this gives the work done during the isothermal compression, isothermal expansion process. And when the heat engine gives some work done on this, some rest of the heat energy is given to the source. And now the carnot cycle is cyclic process. It is the ideal cycle, and it is the maximum efficiency in the form of 1 minus T2 over T. It works on temperature difference. अगर पूछो carnot cycle कैसे वर्क करता है, तो it works on temperature difference. The carnot efficiency की अगर हम बात कर लें, तो carnot efficiency होती है TH minus TC over TH. तो इस तरह से हम बात करें, फाइनली अगर हम बात करें आपसे, अगर आज की स्लाइड की हम बात करें स्टार्टिंग से, तो स्टार्टिंग से हम बात करें तो हम आपको कहाँ से स्टार्ट किए थे. हम बात किए आपसे कि फ्लो ऑफ CO2 क्या होता है. आफ्टर द फ्लो ऑफ CO2 we discussed about the entropy and temperature, and after the entropy and temperature we discussed carnot engine. Basically flow of CO2 में हम आपको ये बताएं, flow of CO2 इस तरीके से होता है, और flow of CO2 का हम आपको एक एप्लीकेशन के थ्रू बताएं कि कुछ एग्जाम्पल ले सकते हैं जिसमें कि flow of CO2 को क्या किया है, गवर्न किया है. और फिर हम आपको टर्म एंट्रॉपी के बारे में बताएं. एंट्रॉपी को अगर डिफाइन किया जा सकता है, तो एंट्रॉपी को हमेशा किसके टर्म में डिफाइन किया जाता है, चेंज इन हीट एनर्जी और टेम्परेचर के टर्म. अगर कैपिटल T है फिर टेम्परेचर है, उस पर चेंज इन हीट एनर्जी TQ है, तो चेंज इन एंट्रॉपी क्या हो जाएगा, TS. और फिर बॉक्स का एग्जाम्पल दिए थे. इस बॉक्स में जिसमें पार्टीशन लाइन पड़ी है, इसकी रेंडमनेस कम थी, तो इसका एंट्रॉपी क्या हो गया, कम हो गया. जिसमें पार्टीशन लाइन नहीं थी और वो वाइब्रेट कर रहा था बॉक्स, उसकी एंट्रॉपी क्या होगी, ज़्यादा. फिर डेफिनेशन आपको बताया, ये फार्मूला बताया आपको, TDS = DQ. आई थिंक ये फार्मूला आपको याद करना पड़ेगा. 2 नंबर में क्वेश्चन आता है तो ये फार्मूला यूज़ कर सकते हैं. तो आई वुड लाइक टू conclude this session related to 3 topics. First one is flow of CO2, because the carnot engine is having a reversible process, frictionless culture inside its cylinder. And why this is ideal, बहुत इंपॉर्टेंट बात ये कहना चाहते हैं कि जो एडियाबैटिक और आइसोथर्मल प्रोसेस होते हैं दोनों एक साथ एग्जिस्ट करते हैं। एडियाबैटिक प्रोसेस जो होता है बहुत कम समय के लिए होता है और ये उसमें हीट क्या होता है, जीरो होता है, और ये एग्जिस्ट नहीं कर सकता प्रैक्टिकली, क्योंकि कोई चीज़ें कोई प्रोसेस बहुत तेज़ी से होगा फिर धीरे प्रोसेस होने लगे तो पॉसिबल नहीं। तो आज के सेशन में जो मेन मेरा मोटिव था that motive is to convey some slides related to the significance of thermodynamics on the behalf of entropy and temperature as well as carnot. Okay.